Hi, everybody. I'm Jorge Carrillo from El Colev in Tijuana, Mexico. And this is a collective paper by four researchers from Colev and two researchers from Axis, which is a consultant business for strategic intelligence to the manufacturing industry. The title of the paper is Are Engineers Able to Transit to Industry 4.0 in the Automotive Sector? The Case of Baja California in Mexico. As you probably know, the automotive industry is part of a set of activities that start implementing the 4.0 early. Connectivity, electrification, diverse mobility, and autonomous driving, as you know, are the part of these 4.0 technologies. These technologies are implemented by who? Mostly by engineers, technicians, and managers. And for that, we call in this paper specialized human resources, who are also conceiving and managing changes towards digitalization for all activities in the companies. Therefore, specialized human resources are in charge of designing, developing, disseminating, and implementing the 4.0. So our question, the research question is, what we know about the level of knowledge of implementation of these technologies associated with 4.0 technologies. So the discussion is, there are a few points. First is 4.0 technologies is done in practice, and that means performatives. So that implies a continuous investment of committed actors. And in that case, the specialized human resources are central to this process. However, the digital divide in human resources is growing as technology evolving faster than knowledge. So there is a broader consensus of the immediate need to strengthen the capacity of both individuals and institutions such as universities. There is also studies that shows that this new, the need of the talent 4.0 gives a new wave of the science, technology, engineering, and math approach. But also, and that is important, is not just technical or technological, but it's also social and personal skills that are needed, such as leadership, language skills, teamwork, organizational skills, and responsibility. Therefore, and once again, like in the lean production, we face a great challenge, both technological and organizational, for instrumentation of 4.0. Okay, the methodology for our study is based on an online survey made by Axis, and we have 164 companies that respond positively to this, the whole questionnaire. And the questionnaire addressed, as I mentioned, to the specialized personnel in 7 industries, all in manufacture, vertical industries such as aerospace, electronics, and medical devices, and the horizontal plastic, metal mechanic, and technological services. So, because Industry 4.0 for us is more than a philosophy rather than a technology, we ask about 20 technologies. You can see in the on the screen those technologies: additive manufacturing, machine learning, augmented reality, virtual reality, autonomous robots, collaborative robots, big data, autonomous cars, cloud computing, blockchain, cybersecurity, IoT, computer vision, sensing and data collection, digital modeling, vertical and horizontal system integration, digital twin, real-time process monitoring, intelligent energy management, and artificial intelligence. So we asked to these people about these technologies. So general results of the survey. First, we found low level of implementation of 4.0 technologies. relatively high level in the automotive industry, I mean, compared with these 7, but is greater in the medical devices and the aerospace. Second, specialized human resources in the aerospace and technological service have a higher level of knowledge than the other sectors. The real-time processes monitoring is the most implemented in most of the industries in Baja California. Just in the case of the automotive industry, we have a low level of knowledge about the 4.0 technologies, surpassed in this respect by all sectors except for metalworking. Second, the autonomous robotics has the better level of knowledge in the auto sector. Third, autonomous robotic, cobots, autonomous vehicles, and intelligent energy management are above the overall average. And finally, in non-technology, the auto sector stands out of the most outstanding. In fact, digital twin, for instance, have the lowest level of knowledge. Second results. 1/3 of the specialized human resources are sufficiently aware of the scope and potential of 4.0, while 50% report that they do not know it sufficiently. Second, knowledge differs depending on the type of technology. We will mention that. A higher level of knowledge in tangible technologies, particularly in real-time processing, monitoring, IoT, sensing, and digital data collection, but higher ignorance in intangible technologies, particularly digital twin and blockchains. So we elaborate 3 hypotheses. The first one is the level of specialized human resource in the auto industry is higher, the level of knowledge of a specialized human resource technologies for 4.0 is higher in the automotive sectors compared with the others. You can see the results, and the results are depending with the higher level in the aerospace and the low level in the metalworking from 70 to 16%, so there is a big difference. So the general results, there is a better level of knowledge in tangible technologies than in intangible ones. This is the same for automotive sector and the rest for the other industry. Second, there is a progression in the level of knowledge that goes from less complex technologies to more complex ones. The same for auto and for the others. And the third progression, the third conclusion is there is a progression in the level of knowledge that goes from less innovative technologies to the most innovative. The same for autos and for the others. So second hypothesis. The first one was related with the level of knowledge of the people. This hypothesis is the level of implementation of the technology related with 4.0 in the companies. And the answer is, of course, by the same people, but this the level is the company. So you see there is the 3 type of technologies, tangible and intangible, the complexity, low, medium, and high, and the introduction in terms of the innovative, so low, medium, and high. And we compare our parts with others. Those are the results. We did this with the ANOVA statistics, and this is the results, the general results for this second hypothesis. And before that, it's important to mention that when we are talking about how extensive is the implementation in companies, results than in the auto parts is higher if we compare with the OEMs. OEMs, not just in the auto, but in the other industries as well, in the 4 sectors that has OEMs. And it's interesting because it's a split between these OEMs, while in the auto parts is 100%. So the general results for the second hypothesis, implementation goes from 40 to 60% is relatively low in the automotive industry. In general, there are no difference between automotive and other industry in the 3 types of technologies. We did a cluster analysis, and from that, the result was 2 groups. In one group is the aerospace, technological service, and plastic, and in the second group is the automotive, medical devices, electronics, and metalworking. So these two groups are different, statistical significant differences. And it's different the level of implementation in both groups, but the implementation is higher for tangible and for less complexity technologies, the same that we showed before. And in all cases, implementation is higher in group 1 than in group 2. The issue is that in group 2 is included the automotive sector. So the third hypothesis, the higher level of knowledge of specialized human resources is higher the implementation of technologies for the auto companies. So higher level of knowledge, higher level of implementation. So we are trying to see if there is a correlation. So the information is here. These are significant, highly significant, and you see the information here with low and high level of knowledge, a high level of implementation. So in the three types of technologies, statistically significant difference in the level of implementations. First, in both groups, in 1 and 2nd, the general trends continues. Implementation is greater in tangible technologies than intangible and less complex than in new ones. However, in all cases, the level of knowledge in group 1 is again higher than in group 2, which includes the automotive companies. So since the beginning at the end, it's a continuous, the same continuous approach. So finally, after these three hypotheses, we did a question: what factors explains the level of knowledge of the specialized human resource and implementation in companies about the 4.0 technologies? In other words, is there a difference between the auto and the rest of the sectors? So we did a logistic regression with company size, level of knowledge of specialist human resources, the level of the degree of readiness of the company to introduce 4.0, and the level of resources the company has in order to incorporate or adapt the 4.0. And it's a dichotomy of variables in all cases. So with 95% of confidence level, the knowledge of a specialist human resource is the only variable, the only one that has a significant incidence on the level of implementation of 4.0 technologies. So not the size of companies, not the readiness of the company, not the resources, but the knowledge of people. So as I mentioned at the beginning, it's crucial, this sector, and this results shows that importance of these people. So there is a positive correlation between knowledge level and implementation level. The more knowledge, the greater the implementation, and vice versa. So conclusions of this paper. Industry 4.0 continues to experiment in both OEMs, tier 1 companies, and SMEs providers. It's important to highlight this because it's a continuous process, and most of the companies are experimenting. What are the best techniques that we can deal? What are the best techniques for our business? What are the techniques that require the clients, etc., etc. So it's an experimentation. Second, engineers, technicians, and managers are the main human vehicle that carry out the development and implementation of 4.0. Of course, this comes from the corporatives, and in some cases the affiliates are very aggressive in order to the implementation. But at the end, these specialized human resources are the most important vehicle for the introduction of the 4.0 technologies. Third, the level of knowledge about 4.0 technologies is critical to their prompt and better implementation. But the Industry 4.0, as I mentioned at the beginning, is just the philosophy that includes dozens of technologies that are with different level of knowledge and level of implementations in the companies. But I'm pretty sure that the immediate future, they will come best practices. So the implementation of 4.0 technologies will be fast and efficient in the results that those companies have a mature lean production system, because lean production is a well-organized companies with the process control, quality control, energy control, etc. So in that companies, a more lean production system, more mature lean production systems, the implementation could be faster and efficient. Therefore, at the end, in the level of knowledge that Mexican specialized human resources have in the areas with a long tradition of export industrialization, such as Baja California, it is sufficient to be able to transit to 4.0, because this is a very specific ecosystem with a long tradition of exports and with a long tradition of best practices such as the lean production. So our response, unfortunately, is not yes or no, but this may be yes, but it's still very limited. Why? Because only 1/3 of the qualified staff of these human resources specialists on this, and half of the companies are prepared for it. So this is an important result, but as I mentioned, and as we know for other studies, usually there are heterogeneity between companies. So this was our main conclusion. Thank you so much. And please visit our webpage where you can find the definition of these technologies and general results of this survey. Thank you so much. Bye.